Hello guys, this is the fashion MNIST data set part 2. In the previous section we are done uh, we are loaded the data sets into the TensorFlow data set and we visualized some images also. Okay, this is the neural network part, this is the model building part. Okay, we do now how to build the model. Okay, I just put the name, build the model. Okay, next step is to set up the layers. Okay, building the neural network is required to configure the layer of the models, the compiling the models. First step is the set of the layers. I just put there, set up the layer of the layers. Okay, basically the building block of a neural network is the layer. Okay, basically the neural network is a layer. A layer extract the representation from the data, feed into it. Hopefully hopefully the series of the connection layers result in a representations that is meaningful of the problem the hand. Much of the deep learning consists of the changing to there are simple layers. Okay, most of the layers like tf.keras.layer.dense like this only have some internal parameters which are adjusted learning during the training. I just start with the model building. Put the one variable name is a model and the normal functionality tf.keras dot using here sequential API. Okay, sequential inside the I creating my first layer that is a keras dot layer dot flatten. Flatten my input shape. My input shape is 28 comma 28. We already know how its input shape is come. My input shape is 28 cross 28. There are okay, in the neural network have a three layers. Okay, what are the layer? Input layer, hidden layer and output layer. This is the input layer of the in this neural network. This neural network is start with the tf.keras.layer.flatten. Okay, this flatten is a very new thing to you. Mostly the image dataset, mostly we are using the flatten as a input layer. This layer is nothing but this layer is transform the image from the 2D array into 2D array to 1D array. Okay, for the example, our image is a 2D array, the 28 cross 28 pixel. We are converting as a 1D array is a 784 pixel. This number is nothing but we already know what is the shape of the image shape. Okay, that is a 28 cross 28. This is the multiplication of these two numbers. Multiplication of the two numbers. This is the very basic mathematical operation thing of the layer is unstacking row of the pixel in the image and line of them line of them. The layer has a no parameter to learn as the only reform the data. Okay, this layer is not needed any parameter. This is just reform the data. Okay, I just move on to the second layer, that is hidden layer. Oh my god, this is keras dot layers dot dense. Okay, these parameters we already seen in the previous examples also. I put the 128 neurons. My activation is tf dot nn dot ReLU. Using the ReLU activation functions. Most of the time we are using the ReLU activation function only in the network, actually the hidden layers. Okay, the hidden layer is we are using tf.keras.layer.dense. Okay, in the dense layer we already seen the previous example also, so that is a very normal things. The previous examples also we are using some number of neurons, right? But the activation function is same, the ReLU. There also we are using the ReLU activation function only. The dense layer is a connecting of 128 neurons. Okay, the dense layers have 128 neurons. The each neuron take input from the 128 neurons, right? The each neurons have take a input from the 784 nodes. Okay, the previous node have a 784 nodes, neurons. There are collected the information from the previous layers, and okay, yeah, the weight information and weights also. Okay, inputs and weights also, the hidden parameters which are be learned during the training period. Okay, this everything is a learned the training period, and output as a single value. Okay, this collected is the 784 inputs value as well as the weights also, but the every neurons output value is one single value. Okay, that is a one single value that is sent to the other layer, the output layer, or other hidden layers. Okay, the next hidden layers, I just move on to the next layer, that is the output layer. Keras tf dot keras dot, okay, layers dot dense. I put the 10. Why I put in the 10 means my output is 10. So here I using the activation is softmax tf dot yeah nn dot softmax. Okay, this is my I just run the thing, something tfs not defined. Oh, I forgot to run the previous things. Yeah, I run the previous also. It takes times, little times. Yeah, this one is done. The library initialize starting is going on. Okay, I come to the part of the output part. I am not explore the output first still now. Okay, the output part is connected. We are having 128 neurons in the previous layer. The every neurons have connected in the output layers. We follow that 10 nodes, right? 10 nodes, the softmax function. The each node represent as a classes of clothing. Okay, the each node represent as a classes of clothing. Okay, we have a lot of classes, right? Pant, ankle boots, jerkin, sandal, right? Those things. Yeah, that is as the previous input. As in the previous layer, the final layer take input from the 128 neurons. Okay, in the layer before it is it, and the output values ranges 0 to 1. The output values ranges 0 to 1. Represent the probability of image belong the class. So representation of the probabilities. We already seen the PPT part. I am putting the one image. The neural process given the 10 different probability values. Only one thing is higher. Another one is everything is nearly 0. So this is same. They given the some probability values. That values ranges 0 to 1. Okay, you just add on the every probability value, the 10 classes probability values you add on getting 1. Okay, this is only the important note. Only one thing is using the softmax activation function. I am using the last output layer. I am using the softmax activation functions, and oh, I think I forgot one thing. Yeah, that is one thing. Softmax function as a that only. Okay, next I move on to the model. Compile the models. Yeah, I put the double slash. Okay, compile the model. Before the model before the model is ready to the training, it's needed few more settings. Okay, these settings adding during the models compile step. Okay, yeah, we need some few more settings also. It's not only needed for the model building, it's have some more settings. What are the settings? Loss functions, optimizers, matrices, this everything is needed. First we done the coding part of the compile. Model dot compile is optimizer. First parameter is optimizer. I using Atom optimizer. The second thing is loss. Okay, I using Terra dot losses dot spares categorical, yeah, crash entropy, the second one. Exactly. The third one is a matrix. Okay, the matrix also very important in the neural network. Accuracy. Okay, this is the that thing. I just run the. I getting one more error. Missing required position is argument. Which one? Okay. I getting some errors here. That is result dot some argument is missing. What is the argument? TF dot keras dot loss. Oh, I think the SS caps. The SS caps as well as yeah, this one. Yeah, SPA or SC. Okay, the I doing something right. That is the worst case. Categorical cross entropy. I think yeah. I think I clicked the auto update and is the wrong. This is the correct. Here the loss function is nothing but is the algorithm or the measuring how far the your prediction output and from the actual desired output. Okay, that is the goal of the measuring your loss. First thing, the optimizer is the an algorithm adjust the parameter based on the loss functions. It is the minimize your loss. Okay, this is the objective of the loss functions. Finally the matrix. Okay, matrix is using a monitoring your training and testing steps. Okay, the following example using the accuracy, the fraction of the image are the correctly classified or not. Okay, this is the accuracy thing. The final was the training the model. Training the model. I put it in here some things. Okay, batch size. Batch size. Okay, batch size is I put that 32. Training. Yeah. Training data set equal to train data set dot catchy. We already seen what is the catchy is taking you store everything is your catchy, your RAM memory. After is taken everything is easily. After I put the repeat. Okay, that is one of the important thing. Is not is useful for the your model cannot memorize anything. That's why I am using this shuffle. I shuffle the training examples. Okay, I shuffle training example dot batch is I already put the batch size. Okay, I just put the here batch size. Number of training example, I think this is nothing but I already stored one value here. This is the number of training example, that is the I mentioned here using here. Yeah, this is my I just once again check my codes. Okay, I started the other things. Test data set. Okay, sorry, I remove the set. Test data equal to test data dot catchy dot batches batch size. I just copy paste. Yeah, that's only. Just I run the model. Yeah, it's done. Here I want to explain this. What are the things I done? I want to explain now. First, we define the hydration behavior of the training data sets. First one is a repeat. Okay, first is I want to explain the repeat function. Repeat function forever the specific data sets. Okay, repeats the epochs parameter describe the below limits how long we are perform the trainings. Okay, this is nothing but the repeat parameter is the repeating the functions. How many times you mentioned here? I mentioned the 60,000. Repeating those times. Okay. The second one is the shuffle. Okay, shuffle is I initialize the shuffle number of training example. How many number of training example we have? We have already 6,000. Okay, 16,000, 60,000. Okay, we want to shuffle the 60,000 example. Okay, the third one is the batch size. The batch size is tells the model fit to use the batches of 32 image and labels updating the model variable. This have a 32 is a batch size. The splitter is a 32 parts. Okay. Next, I want. Okay, I do the fit model dot fit. That is a final one. Model dot fit train data set. Okay, data set. Yeah, correct. How many epochs? I put the 5. Okay, steps per epoch is math. We already initialized the math library. We are using now. Yeah, training example. Okay, divided by the batch size. I think, yeah, batch size. I just click. What has happened? Oh, something is missing or not? Maybe. Yeah, I missed the one parameter. What is this? Dense is incompletable. Okay, I think here I did something. Dense is incompletable. Okay. this is not a training data, this is the train data. Yeah, it's running. I put the one error before, that's why it's happening. Okay, I explain what is happen. Creating the variable non first call as function decoder with the df functions. This line only. The creating the variable as non first call to the function decoder with the df dot functions. Okay, train data. Epochs, 5 steps per epochs is math dot cell number of train example divided by the batch size, that is fine. The previous things also I think are fine only. Test data test data not catch batch size. Okay, stuffle number of training example size. I don't know why it's happened. Hey, what is this? Okay, something has happened, man. Yeah, I don't know what has happened here. Okay, I just explain what is happening. Explore the result training functions. SECATEGORICAL RAS. I think this is the caps. Maybe this issue. It's the worst case. And this is a sequential only. Okay, I just run again. Oh. Everything is almost completed. It shows only one error. I don't know what is the error exactly here. Yeah, Okay, I explained the last function. That is the fit method. The first one is the feeding your training data. Okay, training data, the model. Okay, that is here our training data is trained data. That is our training data. We are feeding the model. The second thing is okay. What's that? Okay, yes. The second one is the model learn and to the associate the image and label also. Okay, the model is associated with the learning images as per the labels. Okay, the third one is epochs. How many times is want to learn? Is of in our model put the 5. Okay, this is means this entire operation is happening 5 times. The entire data set is learning the 5 times. That means 5 into 60,000 images we have. That is 3 lakh samples. This is the case. You getting the we started the training parts. Okay, already the 3 epochs is done. We getting 0.8262, 0.6, 0.88, 0.88. Yeah, we are getting a good accuracy, I think. The loss also is down, right? Startingly we getting 0.49, after is reduced 0.37, 0.32. Now finally we are getting the 0.29. Our highest accuracy is 0.89. That is a good accuracy only. Maybe, yeah. This is the nice area. As the model the training, the loss and accuracy matrix are displayed. Yeah, what is accuracy 0.8925, our loss is 0.292. Okay, this model reached the accuracy above the 88. Okay, accuracy above the 88% on the training data. Now we want to evaluate the model. Once we done, what is the next step is compare how the model is performed to the test data sets. We done the training parts. Now we want to do the testing parts. Okay, how it's performing the testing data sets. Use the all example we have in the testing data set as to the accuracy. Okay, I just put the test loss. Another one is the test accuracy model dot evaluate test data comma step equal to math dot cell. Okay, math dot cell number of test example. This also we already done. Okay, don't worry about anything. Print accuracy on test data set. Yeah, I put the test accuracy. What is the accuracy? Oh, here also getting some errors. What is the step? Okay, this is not a step, this is a steps. Okay, don't worry about this make silly mistakes. Okay, we getting the 87.92. Okay, as the turn out, the accuracy on the tested data set is smaller than, very smaller than the accuracy on the training data set. Okay, this is the completely normal. This is the completely normal since the model was the model was a training on the training data set. When the model seen the images is never seen the during the training. It is from the test data sets, right? This is the different image data sets. We can expect it from the to the go down. Okay, after we make some predictions also. I just done everything now. What we done means now in this part we are building the model. We are creating one model architecture using the sequential API. We have three layers. First one is the input layer. We are using the flatten. Second is the output layer, that is a dense. The third one is the output layer. We are using the softmax activation function especially. The next one is the model compilation. We are using three parameters, that is the optimizer, loss, metrics. Okay. The final part is a training model. Before the fit method, we are doing some things, some setups also. Okay, what is that? That repeating, the shuffling the data set, split the batches. This is the some pre-settings. Finally, we fit the methods. Once we done the training process, after we want to test the different data sets, right? We getting the final accuracy is 0.8792. This is our final accuracy. Yeah, this is the nice one.